Now that we have a method for discussing pitches in numerical form, we are able to begin utilizing quotient spaces in order to model musical spaces. In mathematics, quotient spaces are the result of gluing points together based on an equivalence relationship. The mathematical term for this process is known as identifying, because all the points that were associated together are now identified with a single coordinate. When an equivalence relationship is applied to an entire space, it maps the initial space onto a subspace based on the given equivalence. Here are some examples. Given a cylindrical space and an equivalence relationship which identifies or glues all the points on the top of the cylinder onto a single point, the result would be a conical space. We are no longer able to distinguish between any points on the cap because all the values are now assigned to a single point. Another example of a cylindrical quotient space, which we'll be looking at later, would be an equivalence relationship that glues all the vertical lines onto a single point. This would result in a disk space. Our last example of quotient spaces is based on a disk. Given a disk-shaped space and an equivalence relationship which glues all the points of the boundaries of the disk onto a single point, the resulting space would be a sphere. Rather than looking at purely mathematical equivalencies to construct quotient spaces, authors Callender, Quinn, and Tomatsko lay out 5 traditional musical equivalencies that have been common among analyses for centuries. They are octave, O, which equates pitches under mod 12, permutation, P, which equates different orderings of sets with exactly the same elements, transposition, T, which equates sets whose elements vary by a constant, thereby maintaining the intervals between the notes, inversion, I, which equates sets that have been symmetrically inverted around a fixed pitch, and cardinality, C, which equates sets whose subsets of unique elements are equal. Each of these equivalencies has a drastic effect on the space itself, and watching how these spaces transform provides great insight into the relationships.